Welcome to Visual Texture, a new method for character identification. We have three key aims. Firstly, introduce the concept of visual texture, present a new way of classifying views, and introduce a new character encoding tool. We'll look at uses, visual texture, view classification, character map examples, and then look at ViewCue 4. As a basis for coding, ViewCue can identify character areas that reflect user experience, provide baseline data, establish visual targets, and provide evidence of understanding and change. By assessing the content of Google Street View or bespoke images, ViewCue measures the composite effect of everything that makes up a scene and affects character. We refer to this as visual texture. We combine the measurement of visual texture level and texture type to create a new, unique view classification used to identify and map character areas. We plot visual texture levels from low to high and texture type from urban to natural to create 9 major view categories. Each category reflects the visual characteristics of different locations. These examples illustrate each of the 9 major view type categories, from low to high urban textures on the left through to low to high natural textures on the right. Each one reflecting the combined physical characteristics of the location. We can further break down the 9 categories into specific view classifications. This allows us to provide each view with an identifier based on its level of visual texture and its texture type from urban through to natural. View classification data is easily mapped using the ViewCue toolkit, or easily exported into ArcGIS to identify character areas, zones, and even street segments from Google Street View images. So, let's now look at how we can use the cloud-based ViewCue toolkit to quickly identify visual character and character areas from a street-level perspective using Google Street View or bespoke images. Welcome to ViewCue 4.0. What we see on the screen now is a heat map of the centre of Bath. A heat map showing the distribution of visual texture level of Bath from a survey of 2,500 stations that equates to around 20,000 Google Street View images. The map we're looking at shows texture level. The darker the red, the higher the texture level. The lighter the colour, the lower the texture level. On the right of the screen we can see a dashboard that tells us about the project, its location, number of stations, number of routes, and numbers of views. It gives us indications of the average, maximum and minimum values of texture level, similarly for texture type, and also gives us levels of texture variation along routes. The chart below compares information from this project in the solid line with information as a baseline for all projects in the ViewCue database. On this chart we can see that the visual texture level of Bath is noticeably higher than the average for the rest of the projects in the database. If we zoom in, we can see what this is showing us in terms of the character of the streets. So, now we're in the centre of Bath. Each of the coloured circles represents what we describe as a station. Each station has 8 views, making up a 360-degree view of that specific point in the city. If we select a station, we'll activate an image gallery, and if we scroll down, we'll see 8 views at that particular location. We'll also notice on the top left of each image our visual classification that we looked at earlier. This is showing us that this street is a highly urban street with a very, very small percentage of vegetation. Down here we get the visual texture level of almost 7.5, and if we hover over the fuel gauge we get an indication that this image contains less than 3% vegetation. If we want to see a place with a low level of visual texture, we can select a light coloured station. We can immediately see a difference in the character of the place. We can see much longer views, lower levels of enclosure and more open space, but with a slightly higher level of vegetation. leading to a visual texture level of 4.7 and a vegetation estimate of around 6%. Let's scroll back up and we can look at the next type of data that's available. At the moment we're looking at the visual texture level as an average for all images at each station. But we can choose different view types. We can choose to examine information for vistas forward and back along the street, and you'll see the chart down here has changed to get a different profile. We can look at the information just for the elevational views on either side of the street, and again you'll see that the profile on the chart has changed. Or we can choose to look at views that are 45 degrees etc., the oblique views, and yet again you'll see that the chart has changed. Let's go back to looking at all views, at the average texture level for all views for each station. And now let's change from looking at texture level to looking at texture type. So, when we looked at our first street, we saw that it had a high visual texture level, but it's a very tight urban street, and so its colour is orange on our type scale. If we scroll up and choose one of the green type circles, we'll see a visual texture that is predominantly a natural texture. In this case, the view is classified as an X100. It has a very high visual texture of almost 8.5, with around about 55% of the view being comprised of green vegetation. So far we've looked at the visual texture level and the texture type. Now let's look at them in combination to arrive at our view classification. Now we can see a map that we're familiar with, that we looked at in the earlier part of the presentation. We can see the distribution of different texture types, from the highly urban textures to the highly natural textures, and conversely the low urban to the low natural textures. And we can see distinct character areas starting to emerge. If we look to the right of the screen, we can see the 9 broad categories of view type. The percentage figures tell us the proportion of stations that fall within each of the view type categories for this particular project. The figures in brackets show the baseline of all projects in the ViewCue database. Immediately we can see, standing out in dark purple, the historic core of the city. Lighter purple indicating locations with a slightly lower but still highly urban texture, and then those locations dominated by vegetation emerging on the periphery. To see this data in more detail, we can select the category reporting button. This opens a new window and will show us how many stations are sitting within each of the 9 broad view type categories. Scrolling down to the view classification matrix, the numbers tell us how many stations fall within each of the more specific individual image classifications within the main category types. So far we've looked at percentages and numbers of stations, and stations are collections of 8 images, but we can also examine this data by individual view and by view type. We can select views rather than stations and turn off some of the image types to only look at vistas. This allows us to see what these view classifications look like on this project. If we select the Fetch Data button, we'll see the numbers of individual images that fall within each of the 9 view categories, from our low to high predominantly urban textures, the low to mid-range mixed textures, and the low to high natural textures. Here in the detail matrix we can see the number of images in each of the individual classification cells. This matrix is live if you want to see, for example, what does a T5 look like? What do all the T5s in the sample look like? And here are examples of all the T5s in this project. You'll see just by glancing that they fall into a particular character type in terms of length of view, amount of built form, and degrees of enclosure. Let's look at something by way of a contrast, and instead of looking at a high urban texture, let's have a look at a high natural texture. We'll select X100 from the classification matrix. These are all the images for views that we've recorded as X100. Remembering that these are all extracted from Google Street View, In terms of the speed of extraction, each image takes about 1 second to be selected, processed and recorded. We can also measure the variation or change in visual texture along a route, which has a direct link to the experience someone may have in walking down a particular street. The darker the colour on the map, the more varied the texture along that particular route. The lighter the colour, the more uniform the texture along that route, and therefore the more uniform your experience of moving through that place. Here are 3 examples of routes with different levels of variation. The first example is highly varied, taking a pedestrian through a series of narrow spaces and open spaces, much along the lines of Gordon Cullen's serial vision. We quantify this with a variation coefficient of around 10%. The second example is moderately varied, with a variation coefficient of 3.7%. This final example has a high level of uniformity, where its visual texture changes very little as you progress along its length. Let's return to our combined view categories map. So this is what we started with, and just as a reminder, we could outline the centre of Bath, and we can identify and then specify its particular character. And what we'll do next is to zoom in on this and look at this in more detail, where we'll compare the results of our visual texture survey and our view classification with a more traditional morphological study of the centre of Bath. In 2015, Carl Kropf and Pete Ferguson undertook a tissue analysis of the centre of Bath. This plan shows the distribution of character areas identified in the tissue analysis. Superimposing a visual texture survey shows a clear correlation between the boundaries of areas identified using traditional methods and those areas identified through their visual texture as having a unique character. For example, you can see the historic core, Henrietta Park, and a more recent development to the northeast. In addition to the survey tool, ViewCue also has an assessment tool. The assessment tool can help quantify the degree of change in a view as part of a visual impact assessment, and be used to demonstrate that visual texture targets that may have been specified in the design code have been achieved. And it can help quantify the difference between an existing situation and a proposal or a series of options. So how and when do we use visual texture analysis in terms of character and coding? Use visual texture mapping as the first step in identifying character areas, zones and segments. Use it to establish visual targets within a design code, and use the assessment tool to demonstrate the visual targets have been met. ViewCue 4 can help you deliver the requirements of the emerging National Model Design Code by providing street-level visual data that complements and adds to traditional methods. We've been looking at visual texture and the new ViewCue 4 visual analysis tool, an appraisal method and a tool that can be used to characterize place. Remember, it's street-based rather than area-based. It lends itself to street-based coding. And it's a street-level appraisal that can pick up the hybrid results that occur when 2 character areas or 2 urban tissues meet. This means it reflects user experience rather than picking up abstract patterns just from plan. It adds an experiential aspect to our more traditional methods of morphological analysis, but it needs to be used alongside those methods to create a complete picture and a complete baseline. And as you've seen, ViewCue is quick and easy to use. We can process 1 square kilometre, about 5,000 images, in around 30 minutes. I hope you found that of interest and got something useful from it. If you'd like to know more, then please do get in touch. I've been John Cooper. Thanks very much for listening.